Good day everyone, you're welcome to another exciting video lesson on Master Science Guide. In today's video lesson, we are going to be looking at a very important aspect in the world of chemistry. Alright, now this aspect is a foundational topic that will help and create a solid foundation for your journey all throughout the physical aspect of chemistry, which has to do with the calculation aspect of chemistry. Now, any calculation you want to understand in chemistry, you need to have this basic foundational topic, which is called the mole concept. Now, this topic creates a very wide and broad, solid foundation in order for you to progress, all right, through the journey of calculation in other areas of chemistry, like in electrolysis, like in order to calculate your limiting and necessary reagent for your mass to mass relationship and other calculations in chemistry. All right, now let's quickly run into what we have on the board. Now, on the board, the topic says mole concept. Now, meaning that everything we are going to be discussing in this topic involves mole. All right, involves what? The mole. Now, what does the mole stand for? Now, look at this. A mole is the amount of substance that contains 6.02 3 times 10 raised to the power of 23 elementary particles. So a mole can be simply defined as the amount of substance that contains 6.023 times 10 raised to the power of 23 elementary particles. These particles are either atoms, molecules, or ions. So in summary, we can say that a mole is simply defined as the amount of substance that contains 6.023 times 10 to the power of 23 atoms or molecules or ions, as the case may be. Now, there are so many formulas that cut across mole. There are so many formulas that cut across mole. The most basic formula of the mole is number of moles N is equal to mass all over molar mass. Now, you must know this formula. It is a must, all right? It's cut across all areas in chemistry. Mole is equal to mass all over molar mass. However, there are other formulas pertaining to the mole, all right? Now, for simplicity's sake, I am going to combine all the formulas together to give us one straight chain formula. I'm combining all the formulas together to give us what? One straight chain formulas, all right? So that's one straight chain formula. If you can have it in your head, there is no question involving the mole that you cannot tackle with this chain formula. Now, the chain formula quickly, please. All right, I'm going to wipe this off. So, the chain formula is N is equal to mass all over molar mass, which is equal to volume at STP, standard temperature and pressure, all over 22.4 dm cube, which is equal to CV, volume in centimeter cube, all over 1000, which is equal to PV over ROT, which is also equal to particles, or you can say number of particles all over 6.023 times 10 to the power of 23. This guy is known as Avogadro's number. Alright? So, this is the chain formula. Mass all over molar mass is equal to volume at STP over 22.4 gm cube, which is equal to CV over 1000, which is also equal to PV over ROT, and which is also equal to number of particles all over 6.023 times 10 to the power 23. Now, when we are talking about number of particles, Number of particles simply means is either we are talking about atoms, molecules, or ions as number of particles. Number of particles simply means atoms, molecules, or ions. That's what we mean by what? Number of particles. Right? Now, let's go through the quantities, all right? Or we should go through the parameters. Now, we have C in the parameter there. What does C stand for? C stands for concentration, and the unit for concentration is in mole per dm cube or molar m. We have V, volume. Now, the standard unit for volume is in dm cube. So please don't forget this. Standard unit for volume is in dm cube. Then our arrow is our gas constant. All right, and the value is 0.0821 atm dm cube per Kelvin per mole. Then we also have T, our temperature. T stands for temperature, and our temperature, the unit for our temperature is what? Kelvin. So it therefore means anytime we are giving temperature in degrees Celsius, what do we need to do? We need to convert to Kelvin. So pardon me. Now this one, our molar mass, all right? The unit, the SI unit for molar mass, M mass means what? The molar mass. Right, so the SI unit of the molar mass is what? Gram per mole. Then we also have our mass, which is already there. So N is our number of moles. The unit is still mole. All right. So our P is pressure. And please take note, the standard unit for pressure is atm. All right. Then our Na talks about Avogadro's constant, and the value for it is what we have here, 6.023 times 10 raised to the power of 23. Although some people will also tell you that it's 6.022 times 10 to the power of 23. It's literally the same thing. All right. Now STP means standard temperature and pressure. That's the meaning of STP. Standard temperature and pressure. So STP means what? Standard temperature and pressure. Now, when we're talking about standard temperature, let me quickly explain this. Let's expand on this. When we're talking about standard temperature, what does standard temperature mean? Now, the value for standard temperature, all right? Standard temperature, the value for standard temperature is 273 Kelvin. So standard temperature, the value for it is what? 273 Kelvin. And when we are talking about standard pressure, the value for standard pressure is 1 atm, or you can also work with 760 mmHg. All right, so you can work with 1 atm, or you say 760 mmHg. So that's standard pressure. All right, the standard temperature is 273 Kelvin. All right, so now we have our chain formula. This is it. This is a chain formula. So now we have this our chain formula. Now let's go through some question series so you see how we can apply these formulas. Now let us break down this question on the board. Now the question says 56.00 centimeter cube of a gas at STP weighed 0.11 gram. What is the vapor density of the gas? Now they are asking us to look for vapor density. Now I want to quickly just show you the formula for vapor density. To get our vapor density, our VG, vapor density is equal to molecular mass or molar mass all over 2. This is the formula to find vapor density. So it therefore means that before we find vapor density, we need to know what our molecular mass. So that means we need to find molecular mass so that we can find what? Our vapor density. Now, how do we find molecular mass? We were given 0.11 gram. So the mass, our mass is 0.11 gram. Alright. Then we're given volume. Volume is what? So we're given V. Volume. Alright. But if we read through the question, the thing says 56.00 centimeter cube of a gas at STP. So this is the volume of the gas at STP. So volume at STP is equal to what? 56.00. So let us find molar mass. We want to find the molar mass, right? Now, how do we find the molar mass? Now, remember that chain formula. Now, if you go through the chain formula, you see that we have N is equal to mass all over molar mass, which is also equal to volume at STP over 22.4. But now, look at it. Look at this. N, I want to bring half of the formula. N is equal to mass all over molar mass, which is also equal to what? Volume at STP all over 22.4 dm3. Now, instead of us to use N is equal to volume at STP, so we find N, and later come and use N is equal to mass all over molar mass. That will take us a lot of time. Just look through the entire thing. All right. What was given? We are looking for molar mass. We know our mass. We know the volume at STP, and we know this guy. So it's only molar mass we don't know. So instead of trying to do a lot of things, just take off this N equal to and leave it like this. Mass all over molar mass is equal to volume at STP over 22.4. So when you have it like this, it makes the journey very easy. So now our mass is 0.11 all over. We're looking for molar mass, so we can call it Y. Our volume at STP is what? 56.00. Don't forget centimeter cube. Now we need to convert centimeter cube to dm cube. Please take note. You must convert. All right, the centimeter cube to dm cube. So by the time we convert this to dm cube, how do we convert centimeter cube to dm cube? We are simply going to divide by 1000. So by the time we divide by 1000, all right, by the time we divide by 1000, so we're going to have 56 all over 1000, which will now finally give us 1, 2, 3. So that's 0.056. All right, dm cube. So this is what we will now be working with. This is what we are going to work with. So our volume at STP now becomes 0.056 all over 22.4 dm cube. So no need to add this dm cube. So this will simply cross multiply, and then we have 0.56 times y will give us 0.056 times y will give us 0.056y, which is equal to 0.11 times 22.4. Okay, so let's do that. 0.11 times 22.4. That will give us 2.464. Then at this point, what do we do? Divide both sides by 0.056, because we need y to stand on its own, 0.056. So this cancel out this, therefore y becomes what? So we have 2.464 divided by 0.056. That's going to give us what? 44 gram per mole. That's for our molar mass, but this is not our final answer. Okay, what we just got is our molar mass. Now remember, to get our vapor density, this is the formula. All right, so Vd, vapor density, is equal to what's the molecular mass? 44 divided by what? 2. So 44 divided by 2, that obviously will give us what? 22. So our answer becomes what? 22. That is option B. Option B becomes our answer. Okay, class. Now let's solve this question. Second question. Let's solve the second question. Now it's very, very easy. What volume of oxygen is produced from the decomposition of 2 moles of KClO3 at STP? So you have to find the volume of oxygen that is produced. Alright, so that is volume at STP. We are told to calculate the volume at STP. So what's the volume at STP? Literally, that's what we are asked to find. The number of moles is what? 2 moles. Alright, so very easy question. Just use N is equal to volume at STP all over 22.4 dm cube. So what's our N? 2. Volume at STP, let's just call it X. That's what we are looking for. All over 22.4. So what do we simply do? Cross multiply. X times 1 is what? X, which is equal to 2 times 2.4. Obviously it is 44.8 dm cube. That's our answer. So therefore the answer to this question is option C. That's the answer to this question. Let's look at this next question. It says, what volume of 1.5 molar solution of KOA would contain 0.045 moles? Alright, so we are looking for volume. What volume? We're looking for volume. Then molar. Remember, molar is the unit for what? Concentration. So our concentration C is 1.5. Right? 1.5. Then our number of moles is what? 0.045. 0.045. So don't forget, formula to use. N is equal to what? CV over 1000. So what's our N? 0.045 is equal to, what's our C? 1.5 times V all over 1000. So at this point, what do? We cross multiply. So 1.5 times V is what? 1.5 times V times 1 is 1.5 V, which is equal to 0.045 times 1000. So that's 1.5 V is equal to, when you times this, you're going to have 1, 2, 3. So that's 45. So divide both sides by what? 1.5, 1.5. 1.5 cancel out 1.5. Therefore, V is equal to, when you do this, we're going to get 30 centimeter cube. So our answer is option B. Alright, so this is the final question we're going to be looking at in this video lesson. Alright, so please make sure you stay to the end because there will be an exercise for you to do, and I want you to drop a comment of your answers, alright, in the comment section. Okay, so now how many atoms are present in 6 grams of magnesium? So now we're given the mass of magnesium to be what? 6.0 grams. That's literally saying 6. Then the molar mass of magnesium is given to be 24, and we're given our Avogadro's number. Okay, and the answer to find what? How many atoms? So number of atoms. Now, which of the formula relates more, all right, with Avogadro's number? There's only one formula, which is, normally we have that chain formula, all right? We can use N is equal to number of atoms all over 6.023 times 10 raised to the power of what? 23. But I told you, all right, instead of just finding N, go and use something like this. Now you go and use N is equal to mass all over what? Molar mass. You go and use this to find your N. Then before you now come here and now use the value of your N, that's literally a waste of time. So all you simply do, all right, remove this N here and replace it with what? Mass all over molar mass. So now you got this, you can now proceed. So what's our mass? 6. What's our molar mass? 24. Number of atoms, that's what we are looking for. So we can call it Y all over what? 6.023 23 times 10 raised to the power of what? 23. So by the time we cross multiply, what do we have? Y times 24 is what? 24y, which is equal to 6 times this. We have 6 times 6.023 times 10 raised to the power of 23. Alright? So at this point, we are going to make y stand on this also. We divide both sides by 24. Divide both sides by 24. So that 24 cancels out 24. Therefore, y is now equal to. Now, when you put all of this, 6 times 6.023 times 10 raised to the power of 23 divided by 24, what are we going to get? And this is what we are going to get. We're going to get 1.505 times 10 raised to the power of what? 23. Or we can also write it as what? 1.5, approximate this, you get 1 times 10 raised to the power of what? 23. So 1.505 times 10 raised to the power of 23. Or 1.51 times 10 raised to the power of what? 23 atoms. So whichever you can find, the approximated or the one that was not approximated. So the answer here is what? Option C. So option C is our answer. Thank you very much for watching this video lesson to this point. I really appreciate. Please, if you have seen this video for the first time, please do it to hit the subscribe button and click on the notification bell so that you get notified anytime I drop a single video. All right, thank you very much, and I'll see you in the next video lesson.